Calorimetry is a pretty broad term covering a wide range of measuring techniques that involve heat exchange. It's maybe a little bit difficult to define it exactly, but I've taken a stab at it here on the whiteboard. It says calorimetry comprises processes involving heat exchange between two systems affecting their states in a way that measurement of one system determines something about the other. So if you've taken a chemistry class before, you might have looked at calorimetry in relation to determining whether a chemical reaction is exothermic or endothermic based on the measurement of a temperature change of some other system the chemical reaction was in contact with. That's not maybe the most common thing you'll see in a physics class, but it turns out a calorimetry experiment can be done as a way of measuring the specific heat of a substance by measuring a temperature change that substance induces in, say, some known amount of water. This is one example of how it can be done, that then would let you calculate what the specific heat of some unknown system or some material, unknown material had to be. The only thing I have here on the key concept slide, because I think calorimetry is kind of such a nebulous term in my humble opinion, is this simple formula. And I think if you look online for the definition of calorimetry, one version I saw of the definition is it said that it always involves either heating or cooling, the exchange of heat, but either the system's receiving heat or it's putting out heat. And that's kind of there. Both of those things are kind of there in this formula, but it says Q heating is equal to minus Q cooling. You could also maybe state this as Q in is equal to minus Q out. I put the minus here because generally speaking, if you have two objects in thermal contact with each other and there's some kind of heat process involved, one of them is going to heat up and the other one is going to cool down. And so usually this minus sign is needed to reflect that, or this formula doesn't work out. But we'll look at an example to kind of see how that actually works in practice.